Alright guys, so last week we talked about the LG dryer and I want to go over the LG washer. Do me a favor though, when I'm doing this, zoom in so you can get like the whole, this like in the whole screen, because if people watching on a mobile device, they can't see if it's too far away. So I want to go over this and that, but just want to say, those of you guys that are competing, remember the contest is February 26th. I don't remember what day that was. Let's just look real quick what the actual day is. I think it's a Wednesday. Usually we always have the competitions on Wednesday. The 26th is a Wednesday. I have to send in $30 per student for competition, so I'm sending a check today for your guys' contest registration for those of you guys that are competing. But anyways, this is just a LG washer. I'm not going to go into specific one brand or one washer over the other. This is also very similar to the GE washer. The LG and GE are very close together, like we said, the same thing with the dryer. So let's just break down some of the components here. So here's the motor. Take a look at this and just take a look at what's in that picture of the motor. And I'll go ahead and zoom it in for you. What am I looking at here?
The pins?
Okay, but I mean, what are we looking at right here?
The wiring for the motor from the board
Okay. So where actually is the motor?
in the machine.
Basically?
Underneath the tub, no? This is a washer?
No, it's right here.
Oh.
About the diagram, not inside the washing machine. Which we're going to do a different part where we're going to do hands-on testing with the washer. We're not going to do that one today. We're just going to do the schematic first, and then we'll have another day where we'll actually bring the washer and actually pick out points and do the testing. But this is the windings in the motor. What's unique about that drawing? What's different from, let's just say, this dryer motor here, for example?
Instead of a 2-speed motor, it has 3 coil windings, and you can power, the machine can power either of them.
Well, this dryer is not a 2-speed motor, is it?
No,
Most dryers aren't 2-speed.
no. 2
Why
windings.
are they 1-speed? Let's just, I'm just asking the question of dryer. Why is a dryer a single-speed dryer?
Only really needs to go one direction.
No, actually, Frigidaire, Electrolux, not Frigidaire, the higher end brand, the bigger one. Actually, the motor is reversible on that dryer because the drum is so big that as it rotates, clothes can bind up and like get wrapped and tangled together, so that every once in a while they run it the other direction so it untangles the clothes. But not all dryers do that. And there was a GE dryer that actually had 2 motors in it. One motor to turn the drum and another motor to turn the fan. So again, why a single speed? Do you think if I speed it up, would it be faster?
No.
Would it dry faster?
Single speed, they'll help the clothes dry.
What happened?
They can help the clothes dry at a nice thin pace.
Well, just going over dryers, I know this is a lecture on washers, but just want to bring it up. Dryers, I think the rotation is about 67 to 72 revolutions per minute. That's the drum. Now it's important, and I'm gonna bring it up and I'll tell you a story that happened to me, and then we'll get into the washer. A laundry center with washer on the bottom, dryer on the top, Frigidaire. I was working for BrandSmart in the 90s. Customer complained the dryer was not drying, and it's a brand new dryer. The dryer's 30 days old, okay? 2 or 3 other techs were already out there before me. Now, if a customer calls you and says the dryer is not drying, it's taken 2 or 3 loads to dry, okay? What is the thought process for troubleshooting that? How do you troubleshoot when someone they're not saying it's not working at all.
Right.
They're not saying it's running and not heating. So when you approach a machine for troubleshooting, what do?
Thermistor?
You what?
The thermostat, just
No, we don't go to specific components. We go to components once we focus on, like, what are we going to look for? Like, if I'm telling you it's running and taking 2 or 3 cycles to dry, what kind of information can you do with just that?
Were the clothes drenched? If I hear anything clicking, if the motor's coming on, but
What if the belt broke? The drum won't turn, but the motor will run,
Once then,
and clothes won't dry. Just something as simple as a belt, okay? But in this case, belt was good, the drum is rotating. Now, if a customer tells you it's taking too long to dry clothes, experienced technicians will say, oh, the hose behind the dryer is crushed, or the vent going out the house is blocked, and the air's not going out of the dryer. You got a vent problem, there's nothing wrong with your dryer. Well, this lady's laundry center was in a small laundry room outside, had a hole through the wall. It wasn't even in a tight corner. It was like, just like in this room, I put it right here, had a hole right through the wall, and I could go on the other side of the wall and see the opening. The hose wasn't crushed, the vent wasn't blocked. So now what do I look for? Because I turn the dryer on and I got air flowing out
through the hole.
from the hole. And guess what? The air was hot. So I'm saying I got a problem with drying. I know the drum is turning. I got air flowing. What do I look for next? Temperature. How hot is it? Does anybody know what the high heat of a dryer is? Those of you who've been through laundry should know. William? Paul?
I wanna say like some high number,
Joseph?
200 degrees.
120.
200 degrees, something high.
140 to 160. 120 is low heat for permanent press or delicate clothing. But I went to the back of the dryer, my pocket thermometer, and I was there with the opening in the back. Had 155 degrees. Is that good or bad?
Good.
So wait, it's taking 3 loads to dry the clothes. It's a 30-day-old machine, brand new. Drums turning, air is flowing, and temperature is good. What more can I do? Well, one of the things we could check are drum seals. Both in the front and back of drums, depending on the brand. Like the Whirlpool has a seal on the drum in the front and back. And if one of those seals are torn, it'll pull air in from here instead of over the element, and we're not gonna dry properly. But that wasn't the case.
It wasn't the seals either?
No. So, this is what I did. I took a small sock, threw it inside the drum, opened the door, hit the lid switch, and pressed start on the dryer. I watched that drum go around, and the sock just stuck to the outside of the drum because of the revolutions per minute. The drum was going too fast. Now the motor's single speed, so it isn't a problem with the speed of the motor. You can't change that. Okay? But the drum was going too fast. Had to be 72 things per minute. So I put a tape on the drum and a tape on the cabinet, and I counted every time went around. And I was hitting like 80 or 90 revolutions per minute. I called tech support, and I says, oh yeah, when we manufactured these machines, by mistake, this pulley on the motor, the factory had the wrong size pulley. You know, like on 10-speed bike, they're different size gears, and it changes your speed. And they put the wrong pulley on the motor from the factory. And the only way to determine it was to measure how many revolutions the drum did. Because what was happening with full load is the majority of the clothes were sticking to the outside of the drum. And what really is supposed to happen is the clothes supposed to go here, and when they reach about, let's say, 1 or 2 o'clock position, they're supposed to fall down across the airflow. So that's why it wasn't drying. Now 3 techs before me didn't find it. Why? Because they're probably good mechanics, but they don't have the theory down behind it. You're not gonna need that every day. But you need the theory and understanding how many revolutions per minute. Most of the time, if I told you guys that at the beginning of class, you would just blow that off because like, what do I care about how many revolutions per minute it runs? But that's just as important as going and knowing how to check voltage or resistance on a part to see if it's good or bad. Because not every problem you're gonna run into is an electrical or mechanical problem.
I got a question.
Yes, sir.
Is every brand the same way with the rotation?
Every brand has got to be about that same revolutions per minute, because anything faster, the clothes will stick to the outside of the drum, and if it goes too slow, they'll just tumble over and not go up. So you have to be in that ballpark of the revolutions per minute, and brand doesn't matter. Okay? So that was the dryer. I actually was pretty proud of myself to find that, because I mean, that's the only time in 40 years I've ever seen it. Never seen it again. But that could happen if someone went before you and serviced that machine and put the wrong size belt or something on the machine and now changed the RPMs of the drum. And you wouldn't know it. You would not know it. But if you saw the revolutions were different and said, has anybody ever serviced it? Oh yeah, a guy came out last month, put a new belt on. Ah, wrong belt. Okay? So let's go to this washer here. Most washers, the diagram, I'm trying to level out. Most washers have a run and a start wind and everything else. Does this have a run and start wind in this motor?
No. They're all run and start.
They're all running?
They're all run and start. They can all be run and start.
Okay, so is any of them a run or a start, or they're all run windings?
They're all
right?
run windings, yeah.
Okay, so this is a three-phase motor. Whenever you see three-phase, you're going to see UVW. Each one of those letters is just a different phase in electricity, like line 1, line 2, line 3. So they take a single-phase circuit of 120 volts coming into the machine here. What did I just do? I have more problems with this software in this computer than I do anything else. Okay. So we have, okay, 3 times and we're out, guys. Let's try that one more time. Make it smaller. Where's power come in here?
Power cord. I got it.
Right there, power cord, very good. The power cord goes into a noise filter. Alright, that's how much voltage is coming in there?
110.
120, 110, black and white and ground. Now for those of you new, before I get back to the motor, what is a noise filter?
The sound of the electric. It's for the electric. It makes some electric makes sounds.
You are right, but anybody else give me a little more definition?
I don't got the real definition of it. I don't understand.
Okay, so a noise filter is like a crossover in a stereo system. Well, a crossover, back in the day in stereo systems, they had these little boards called crossovers. And if you had a subwoofer, you only wanted the bass to that speaker. You don't want the highs, because the highs will damage the coil of that speaker. And then the vice versa. Your tweeter, you don't want the real deep bass in it because it'll blow the tweeter out. So what a crossover did is they had either capacitors or a coil of wire that would take away like the bass frequency, so only the high frequency would go to the tweeters. And then the vice versa with the subwoofer. Well, noise filter is basically a crossover. It's supposed to take the real high frequencies and the real low frequencies and prevent them from feeding back into the wall of the customer's home. Because this motor is a frequency drive motor. And what that means is that we have, I wish it would stay still. We have AC voltage, and I'm not going to go into it too deep, but we have something called a sine wave, AC voltage. Every one of these is a pulse of voltage. This is 0 volts, this is 120, 120, and it's AC, so it's going one way, then going the other way, and so forth. 3-phase would be that this is another one here, and then we got another one here. So we have 3 different phases of electricity, 3 different pulses at different times. That's why they call them phases. I'm not gonna get too deep into it, but what happens is that this board here has a set of diodes and other components that take a single phase and convert it to three phase. And I'll get into that in a minute. That's feeding this motor. Now, when we check this motor, we really can't check voltage to this motor because the voltage varies. If I want the motor to go faster, I want it to go slower, I change the voltage to the motor, but I'm also changing the frequency. So that's why we want to have sub meters, and I'll show you on my Klein. And Corey, I was talking to you about frequency earlier. Where's my Klein meter here? Have it here. Oh, here it is. It's in the bottom of my back. So my Klein meter here, and I'll show you guys, has an HZ setting on this. An HZ, you see it?
Yeah.
See that? I know you don't see it too well, but that's HZ right there. You see that? HZ stands for Hertz, and Hertz is the frequency. Okay? When you test some of these washers and you're checking the water level, some say water level switch, but some washers don't actually have a switch. Okay? They have a frequency pressure control. So as water comes up, it changes the frequency of the voltage. So when you go through diagnostics on some of these LGs, when it's empty, it says 255. Well, that's the frequency when the machine's empty. But as it fills up, the 255 actually goes lower. The numbers go lower. So this here allows you to measure frequency. Now, on a drive motor, we don't get enough information from the manufacturer to tell us the frequency that's supposed to be driving that motor.
Wow.
So you're like, well, then how the hell do I check it? If I had a dryer motor not working, I go to the motor and I check to see if I got voltage. If I got voltage and the motor don't work, the motor's gone. So I go here, oops, let me undo that. One second, I want to go to this, here we go. So we go back to this motor. How would you check this motor? Any ideas of how to check that motor?
Line one, and,
Well, you can either do it from the motor or you can do it from the board. We can ohm it out. So I could check 2 to 1, and if I check 2 to 1 and I follow them down, that goes through these two. If I go 1 to 3, 1 goes down, it goes through those two right here. And if I go 2 to 3, it goes through those two. So there's always 2 of them in series when it's running. Now, when you guys work on this machine, I printed this document here, which basically shows you every component, the door switches, the lock mechanism, the water valves, heating element, and the motor's somewhere here. Well, look at this real quick here. I'll get back to the motor. What do we have here? Water level frequency of 25 to 65.
Where did you get that from?
Okay, this came out of the tech manual, but I put this together. I wrote it, all the words, and made it easier so that when you're troubleshooting or working on the machine, you can follow this, but a lot of it's in your service manual. Okay? Those of you who recently had me copy stuff to their drive have that on their drive under LG washer. Okay? But if we go down further, that's all water level frequency. Here's the motor, and here's how to take it apart. So when you guys are taking it out, it tells you how to take it apart. And if we go even further,
Sorry, real quick, is that supposed to say ball sensor?
Hall sensor, H-A-L-L. Because a guy named Hall invented it. I'll explain that in a minute. We haven't got to that part yet. So this is actually part of the motor. These are the windings. And you can see this picture, pin 321, I put them there. And basically you check the resistance through 1 and 2, 2 and 3, and 3 and 1, and all of them should give you a reading of 5 to 15 ohms. All three should be identical readings.
Identical.
Yes. So if you check the motor and you got that resistance, remember I said you can't troubleshoot it for voltage, so we'd ohm it out. If it ohmed out good, the windings in my motor are good. There's nothing wrong with the windings. This part is functional.
What if you got like 8, 8, and 12?
Then there might be something wrong. They should all be identical readings, okay? And here I'm just showing you the testing. Now, Hall sensor testing can't be done with a regular ohm meter. You have to do that through diagnostics. So it cannot be tested with a volt ohm meter. I tell you right here. And I tell you instructions on how to troubleshoot the Hall sensor with that. So what happens is you saw the 3 terminals that we tested it. If you see right here, the Hall sensor is located right next to the motor. Now, if we look at the diagram, let me go back to the other screen. We look at a diagram, this here is the Hall sensor. So that's the Hall sensor, that's the motor winding. The Hall sensor can be replaced on its own. It does not need to be replaced with the entire motor. So if the windings are good, this part can still be at fault. What does the Hall sensor do? Senses that the machine's out in the hall?
Control the speed of the motor.
Speed and direction, but very good. So what happens is, the simple idea of a Hall sensor is it's a coil of wire, and the motor's got something magnetic. So every time the magnet passes the coil of wire, it tries to magnetize the coil, which sends a pulse to the board. And depending on which way I'm turning, that's why you got a Hall A and a Hall B, there's actually 2 of them. And depending on which one gets triggered first, it knows, oh, it's going counterclockwise or clockwise. And then if it goes this way and this one pulses for that one, it's counterclockwise, and also how fast it pulses can tell how fast the motor's going. That's just so the motor can monitor, just like when you drive, your car has the RPMs, but that's only to let you know how fast you're going. That's what the Hall sensor's doing. It's letting the board know that the motor's working, the drum's spinning, and this thing is working. There is no belt on this washer. This motor is directly attached to the spin basket, and when that turns, the motor turns. It's all one piece, okay? So we can ohm out these 3 from here on the board. We don't need to go down to the motor to confirm it. Now, if you ever tested these 3 and you didn't get a reading on one of them, don't immediately assume the board's bad. Go down to the motor and confirm the motor does not test good, because these are connectors that connect wire harnesses together, and we can have a broken wire or a bad connector between the 2. So I'm reading here, I'm not reading there because this connector has a burnt wire, a cut wire, or the connection's broken, and I don't want to go and order a motor and come back and change the motor and find out that's not what it is. I've learned a long time ago, working for big companies is good, but the thing is you don't always get the call you ordered the parts for back. You might get someone else's parts call. Now you got a washing machine with a transmission, and Cecilia and I were working on that washer for 2 days trying to get the transmission apart. So imagine you go to someone's house and a tech orders a transmission. It took you 2 days to get it apart, and you put it all back together again, and the problem's still there. The transmission didn't fix it. That would piss you off after you spent all that effort to fix something that someone else ordered and made a mistake. Now, if the guy did it all the time, you can be mad at the guy, but I make mistakes. I misorder something sometimes. So what I learned in the trade is if I didn't order it, I want to take a minute and confirm that's bad before I take the whole machine apart and start testing. Last thing you want to do is take it all apart and change it and put it all back together and find out you didn't even fix the problem. The problem's still there. You know, it's very hard to convince a customer that the part ordered is wrong, unless you put it in and it's wrong. The last thing you wanna do is actually do all that work, okay? So, that's the hall sensor. What is a thermistor? I talk about this every time I talk about machines. It does temperature, but how does it work?
Well, probably control how hot the dryer get with it, burning cold on the timer.
It does control how hot the dryer gets, but how does it actually do that?
From the board. I mean, from the, like if you want to,
Excuse me, just one second. Pause that for a second. And PTC, and I do this almost every lecture, negative temperature coefficient or positive temperature coefficient. What that means is at room temperature, this part has a specific resistance value. Let's say like an oven. Most oven sensors at room temperature is 1050 ohms. At room temperature at 77 degrees. Okay? Most those. Frigidaire now has changed it to 550 or something, but anyways, NTC is when the temperature goes up, the resistance goes down. Negative means they're opposite each other. Now, if the temperature goes down, what happens to my resistance? It goes up. But PTC is temperature and resistance. They go up and down together. Usually, PTC is in heating, and NTC is usually in cooling, like in refrigerators and air conditioners, stuff like that.
so it'll work for the, a dryer, because the dryer have a cooling setting.
Say that again, sir?
The dryer have a cooling setting.
Yeah, but that just turns the heat off.
Oh, okay.
It just cool, dry is, there's no heat at all.
Okay.
Okay, but what this does is it's sensing the temperature coming out of the dryer, and then once it sees that we're at 140, 160 degrees or whatever it's designed for, it tells the heating element to shut off. Now this is a washer, so why do we have a sensor for the washer?
Hot water?
Yes, now we use hot water from the home, but sometimes we have cycles called Sani wash or something like that. Sani wash is for sanitary purposes, so it gets it much hotter. Imagine like when we had COVID. Someone in your house had COVID, you want to wash their sheets. Well, you put Sani wash and it washes it at a hotter temperature to kill all the germs. So they take the heating element, whoops. They take the heating element here. Where's the heating element? Right here. They have this heating element here. Now why isn't the thermistor here on this line? Because isn't that thermistor controlling that element?
No,
It is controlling the element.
it's not on it. Isn't the thermistor checking the pressure, the temperature of the water itself?
Yes. But that's what tells the heater to shut off. But if we look at this diagram, okay, we have the heater here, but the thermistor is way over here.
They connect through wire,
So what?
through wire.
No, but what happens is,
So it goes back to the main.
this is just to the board, so the board can say, huh, how hot is the water? And then over here, we have a relay, a switch, and a coil of wire, which turns it on or off, based on what that thing says over there. Now, why is that important? Because you go to someone's house, and you see it's not heating. Could the heating element be bad?
Could be.
What else is there besides the element? Look at the
The switch.
schematic.
It's
A what?
switch.
Not a switch.
The door lock switch.
No. Where the heating element is. Nobody sees it?
Door lock, switch.
Fuse.
No, sir.
But the ground.
No, sir.
Fuse.
Who said that?
Oh, the
New
fuse.
George? It's got a fuse inside of it.
Fuse.
But if you look, there's a dotted line all around it. That means that the fuse is bad or that is bad, they get changed as one part, one piece. That's what that dotted line means. It's all one part. Okay, but what if this tested good? I go to the board and I test it and I get, I don't know, let's see how much my resistance value should be according to that paper that I created. Let's see where the heat element is. Right here. Here's the heat element here. Does it have the resistance value? Let's see if it has it here. Right here, between 1 and 2. What should I get? 15 ohms plus or minus 20%. So 20% of 15 is 3 ohms higher or lower.
So 18.
So it could be as high as 18, as low as 12 ohms. Anywhere in that setting, the heat element's considered good. Right? But if we go a little further down, that is the element, that piece right in the middle of those two circles, that one and that one, that's a screw to hold it on. That's the wires there for the element. That is the thermistor. It's right there next to the element. And it's sensing the water temperature there and telling the board what it is. If you look, this isn't exactly that one, but this is one of those thermistors. And the resistance value at room temperature is 60,000 ohms, but at 212 degrees, it's 3 ohms. Is that a PTC or NTC thermistor? Why is it NTC?
Because as it goes up, the resistance goes down.
Yeah, we went from room temperature, which is about 70 degrees, and we went to 212. So what do? Go up in temperature, right? Well, this is the resistance at room temperature, but the resistance dropped from 60,000 to 3,000. So that's an NTC, negative temperature coefficient. So this is the sensor for that board. So if that sensor's bad, will the element work? No. So in other words, when you're troubleshooting, we're not gonna just troubleshoot the element, we have to look at the sensor because that will stop the element from running. Does that make sense?
Yeah.
Okay, so let's go back to the diagram. Now, I'm gonna give you guys tomorrow some troubleshooting questions for this washer, by the way. Let me add one more thing for this noise filter. Noise filter is just power in and power out. You check it by checking 120 coming in, which is coming from the plug, checking 120 coming in, and 120 coming out. If I have 120 on both sides, the filter's good. The noise filter sometimes looks like a capacitor, sometimes looks like a little board or a little box. All microwaves have a little noise filter, and also the fuse is on that same board. There's a little board with some parts on it and a fuse. That's the noise filter, but also the fuse for the main microwave. Okay? So let's look at here. How many pumps do we have?
2.
We have 2 pumps. So they have 2 separate motors and pumps down on the bottom. One to circulate the water while it's washing, sends the water up to the dispenser, dispense detergent, fabric softener, bleach, whatever it is. And then the other one is just to drain the water right out of the machine. Some of these washers only have a single pump and it's just for drain. There's no recirculation. If they want to dispense detergent or soap, they just turn on the water that's coming in from the wall and it goes into the dispenser and washes the soap down in instead of circulating the water. So it's all designed to manufacture, because if they can put 1 pump instead of 2 and use the water valve, isn't that cheaper than having 2 pumps? So it's all a manufacturer's setup. Now if we take a look at this is the door lock mechanism. I'm going to go over that in a minute, but I'm going to go from my sheet to show you how it works and how to test it. Okay? We got 4 water valves on this. We got hot and main wash. These 2 is hot and cold. I think that's the cold. Let me see if they have another cold valve in here somewhere. No. So they have hot and cold, And then these two are for pre-wash and bleach. So this one would go into the detergent dispenser. This one here would go to the bleach dispenser. And they would put water in to dispense the bleach. Okay? Now, we got a pressure switch. That is not really a switch because it's a frequency drive. It's called a pressure switch because that's what we called it for so many years. It was an actual switch that opened and closed and turned the water on and off. Ball sensor. Anybody know what that is?
You have a ball in it?
Ball sensor is not on all machines, but it's actually like a little circuit board with like a little ball inside of it. And if the machine is off balance, like the clothes are not balanced inside when it's spinning, it'll shake violently and that sensor will bounce around and the machine will stop. And then what it'll do, it'll slowly tumble and wash, trying to level those clothes out and then ramp up. It doesn't go from 0 to 100 right away. It ramps up slowly in stages that if it is off balance, it doesn't destroy itself. If it can't correct itself after 2 or 3 times, the machine will shut down. But that device there is to prevent it from destroying itself when it's spinning. Okay, so that's an off-balance sensor. They call it a ball sensor. Let's take a look at the door lock mechanism. Okay, we'll start off here. So there's a few parts in the door lock mechanism. You can get to the door lock without having to take the whole machine apart. Just open the door, take the ring around the rubber gasket in the front, move the gasket, you can get right to the lock mechanism without taking the machine apart. So if you're competing in a contest and you think this switch is bad, you want to be able to check it right there without having to take all the panels off the machine. Now this unit has one switch, 2 PTCs, and a solenoid. What's a PTC? I just got finished telling you guys. Right?
Resistor that goes.
It's a temporal coefficient.
Yes, but a thermistor, we use the temperature resistance to monitor temperature. What they actually do is when electrical current is flowing through there, it gets hot and the resistance goes up. And what it does is it blocks the flow of current from the solenoid so that it doesn't try to unlock when the sensor's hot. Because this resistance going up will drop the voltage there. Now there's 2 switches or 2 things that happen inside the door lock. What are those 2 things?
Lock.
The solenoid is,
So, yeah.
sorry.
I don't know what I say in English. And one is when the door is together, and the other one when the door is locked.
Correct. So what he's saying is like, this thing has to know whether the door is open or closed because it's not going to try to lock if the door is not closed. That can either be done mechanically or electrically. In this case, it's done mechanically. Like when the door closes, it's got like what they call a strike that goes inside the lock and pushes something. And if that don't push, even if you try to energize the solenoid, it don't move. But on some machines, there's 2 switches. When you close the door, one switch closes and the board says, hey, I can lock now because the door's closed. And then the other one, once the door locks, closes and tells you it's locked. But in this case here, we only have one switch. So let's go ahead and take a look at it. So once the lock switch is removed, locate the terminals and numbers are back, and they're located on the wiring diagram. But we're looking for these numbers down here, not those numbers there. These are the numbers that are printed right on the switch. See that? Okay. So now if we go a little bit farther, from 2 to 4, I should be getting a reading from 700 to 1500 ohms. So if I go from 2 to 4, and if you look at the yellow dotted line, I'm going here through this PTC and I'm going over here, and that is the first test you want to make to see if that PTC is good. So when you guys competing, I got a couple of problems with two of those LG washers, each one has a different problem in there, see if you can figure it out, okay? We're using this troubleshooting guide. So you're gonna check between 2 and 3, or 2 and 4 actually. 4 is here and 2 is on the end. And you should have a resistance value of 700 to 1500 ohms. Now between 3 and 4, I get 60 to 90 ohms. And that's this one here. I don't know why this is, okay, I don't know why it wants to do that. So 60, 90 ohms from 3 to 4. And now I'm like going through a PTC, but I'm also going through the solenoid. And what's a solenoid do?
When it gets energized, it magnetizes.
Yes, and that magnetism is going to pull the lock or unlock the lock. A lot of times they have two solenoids, like the GEs have two solenoids. And one pulls the lock closed, but the other one pulls it open. So one locks and one unlocks. In this case, it's a single one. And what Electrolux does with like some of the, like even the dispenser on the ice machine, like it'll pull and lock, and then if I energize it again, it unlocks itself, the same one. Just pulls it, locks, pulls it and unlocks. So once that locks, it closes that switch, which completes a circuit. So this one here is 60 to 90 ohms that you're going through these two components here. Now if we go here, we want to check between 5 and 4. What am I checking between 5 and 4? The actual lock switch. Now I should only be able to check that when. When should be the only time I should be able to check that switch right there.
When it's closed.
Not when it's closed, when it's
Energized.
locked. Because if the door may be closed, and may even physically be locked, but the switch may not make contact. Now, I didn't tell you, but there are certain errors that go with it. You guys have the service manual on your drive, the LG washer, and that'll tell you the error codes and how to figure out what the error codes are. But I have two LG washers, and those will be good practice for the competition, because it's gonna be an LG washer and LG dryer in the competition. Okay? So that is the lock mechanism and how to check the lock mechanism. The pumps, I'm not really gonna go over. I just wanted to go over basically how to check them. Now, on some of these washers, again, I don't know the exact model we're going to have. This particular motor only has really one main board. This main control board running around here, which says main PWB. What is that?
Display board UI.
The display board and UI. Do you guys know what UI is?
The code.
User interface.
User interface.
No, what UI means what?
User interface.
User interface.
User interface. So those are just buttons you press and the machine responds to it. That's what UI means. So if you hear someone say, oh, the UI is bad, they're saying the touch part of the machine. Even this, when I touch these buttons, these are the user interface. I'm the user, and that's how I'm interfacing with this machine, and that's what user interface is. Okay, on a washer, dryer, or any other appliance, all those buttons you press are the user interface. They are what's communicating to the main board and telling the main board what's going on. Okay, so on this particular unit, we don't have a motor control board. On some of these machines, we have a motor control board. Oh.
Yeah.
Where's the motor control board on this one?
Motor control board is just part of the main board.
It's part of the main board. Same thing with refrigerators. These compressors on refrigerators are three-phase like this, VCC compressors. And they have, Frigidaire has a separate little board on the compressor, which is motor control board. But if they don't have it there on the compressor, it's part of the main board. I have a video online where I talked about Samsung refrigerators and the boards in the back. And one of them had like 5 different boards back there, a motor board, a noise filter board, a motor control board, another board, I don't remember what the other one was. And then I went to another Samsung, just like that one, and it only had one main board. And the motor board and the other parts were built in to the main board. And I explained, you see this part of the main board, This is what controls the motor. This part is the power supply coming in where the noise filter is. So they took everything and instead of separate boards, they built it all on one main board. Now, it's cheaper if they put everything on one board,
Right.
instead of making 5 different boards. And you only need to carry one board instead of 5 different boards on another refrigerator to service it. So it makes it actually better for the technician if we only have one board.
Yeah, right.
So
That's-
if I got this washer here and everything's working but the motor, and I own this motor out and the motor checked good, what would you replace?
The motor.
The board. If it had a separate motor controller, but everything else worked, but the motor ohmed out good, then you change the motor controller. There's not a lot to it, you just need to know how they work and then how to troubleshoot it out. Is there any question on this? I didn't spend a lot of time on it, but what I'm gonna do is I'm gonna come up with some troubleshooting questions for tomorrow and let you guys work on it tomorrow, and then next week's lecture, I'm gonna go over those answers and explain, okay, what does this mean and how would you troubleshoot that? In the meantime, I got a couple machines with all kinds of problems. I got a refrigerator not rolling over there, the Whirlpool one. I got the 2 LG washers with problems on them. But you may see notes on there that saying there's a problem. Don't go by the note. I want to know exactly what's wrong with them. Okay? So that's what I'd like you guys to practice on. Otherwise, guys, that's it for today. Have a good day. See you tomorrow.